So, call me Aaron. For the past few days, I have been thinking of starting a YouTube channel. So, this is it. I have started the YouTube channel, and the context will be about making and synthesizing different kinds of chemicals. You can see I have synthesized many chemicals, but still I want to publicize my processes. Okay, so I live in an apartment and I don't have much space to make a lab for myself. But what about a box window? I can just use it. So I transformed it into a laboratory of mine. And I'll be the one who will be guiding you through all the videos that will be posted in this channel. So let's get started. So what we need is very simple. The chemicals and filtration products, 2 jars. I've got a beaker and I don't have beakers of the same size, so I've taken a random glass jar. We are going to need calcium hydroxide. Put this thing away. Yeah, calcium hydroxide. This thing is sodium carbonate. We also don't need this thing. This is sealite. This is my funnel, some cotton, okay, and a pair of gloves. And because the sodium carbonate is very powdery and dusty, I need a mask. So let's get equipped and we'll start the video. So we have taken 50 ml of water. Now we will first dissolve the sodium carbonate. And for a reminder, dissolving sodium carbonate directly generates a lot of heat, but I am prepared for this. We dumped in the sodium carbonate, which I prepared by heating baking soda. Okay, it is too warm, I must say. It's turning into a solution. Okay, the solution turned a little cloudy, which is no matter. Do not fear, because it is in suspension and it has become a saturated solution. So now what we are going to do is add calcium hydroxide, which is also very cheaply available. You can see a precipitate forming. It is actually the formation of calcium carbonate and sodium hydroxide solution is forming too. We need to add quite a decent amount of calcium hydroxide so that all of it can be converted into sodium hydroxide. Here displacement double decomposition reaction is occurring, and here the hydroxide is getting transferred from calcium hydroxide to the sodium carbonate, and the carbonate radical is getting transformed, or rather transferred, to the calcium ion, which is forming calcium carbonate, which is the precipitate you can see here down here. Okay, so now let's give this thing a good shake. Let it stand for quite some time. Until that moment, we'll be preparing our filtration system, which is going to be cotton and sealite. I've made the sealite myself by pounding the hammer on sand, making it superfine powder. So I have added all the cotton. Now time to add the sealite. and spread it around. This will do the job. Now let's place it here. Something is escaping. Okay, that will be no problem. So we have got a filtration system ready. Here is the solution, and now we are gonna just pour it in. Okay, now we are pouring this entire solution inside. We should be getting a clear solution, which I think I am, as witnessed by the solution getting collected over here. You'll see that it is colorless quite a lot. Also, we will add the calcium carbonate because we want to extract all of it. Sodium hydroxide is a very important base in the laboratory, and keeping it is very good because it is used to do and perform different reactions. So I think this is sodium hydroxide solution. We'll test the pH and then we'll be done. As for the top, we can see that this is perfectly calcium carbonate. Yeah, that is perfectly dry and white and hard, insoluble. That is definitely calcium hydroxide. Okay, so I think the filtration is totally complete now. Yeah, the filtration is complete and final drops are falling down. Everything is going on perfect. The solution is quite hot, as well as from the vapor inside here. Look. Okay, the solution is quite clear. I want to take each and every bit. Okay, so here is the filtrate. It is quite clear, but it is still a little bit of dirtiness left inside, so I'm gonna filter it again. I've cleaned the beaker and the funnel, so we are gonna filter it again. The solution is very hot and we should, according to my reckoning, get a clear solution. Please hope that we get a clear solution. Come on. It's a little yellow, but it's fit for my usage. Now we have got this sodium hydroxide solution. So now let's do a very common testing, which is the pH test. I have got my pH paper. Okay, here we have got this. I will take my dropper and show in front of you that it turned totally purple, which is the sign of a very strong base. You can see that how purple it is in comparison to the yellow, and according to the sheet it is exactly between 13 and 14. So this means this is sodium hydroxide, totally purple. Okay, great. So we have got sodium hydroxide. If you want, you can boil it to dryness and get the dry sodium hydroxide, which I cannot show you in this video, but I will do it, and later you will see the usage of the sodium hydroxide in later videos. Okay, we have got sodium hydroxide. Here another note of confirmation that this thing is sodium hydroxide, which many of you may not be believing, is witnessed that we know that calcium hydroxide, which is the only hydroxide present here, is uh, very little quantity can dissolve in water. A very little quantity can dissolve in water. So here the pH is quite high, and if we try to attain the same pH with this little volume of water, which is just below 50, it's going to be a colloid solution. Like, no way that much calcium hydroxide that can turn this paper violet can be in this solution and become crystal clear. Okay, so this was the way how I made sodium hydroxide. Do not try to attempt this thing, but if you really need, you can try this. This is very very much cleaner process than buying it, because it is totally overpriced. As for now, goodbye.